Hello, everybody. Uh, Thank you for joining. This is the fourth edition of TSDSI Tech Deep Dive. And this is the session one, which is on critical communications. So, very warm welcome to each one of you, to all the keynote speakers, the panelists, and the audience for taking the time to join this session one on critical communications. So we're really excited to have you here. Uh, I would like to start by just giving you some context of critical communications. For those of you who are not extremely familiar with critical communications, it's a subject that is referred to wireless communications, basically including the mobile systems, radio systems, and network infrastructure that provide reliable and secure communications. Sometimes it's also referred to as business critical communications or mission critical communication networks. So we use different names, but the essential part of critical communications is the ability to have a very reliable and secure networks which is available at all times. So, although critical communications is largely used by the PPDR agencies. What I mean is the Public Protection and Disaster Relief Management. It is starting to become more popular for various other verticals as well, such as maritime, railways, and other vertical industries like utilities, ambulance services, and so on. For almost 2 or so decades, largely the critical communications were supported by technologies such as Tetra and P25 systems, and even in some cases analog systems. But as we are moving into more broadband infrastructures and networks, there is a big effort to be able to start leveraging these broadband communications for critical communications, namely 4G LTE and the very recent 5G standards and deployments. And globally, from a standardization space, you may be aware that 3GPP has taken on board the support for critical communications or mission critical applications in 3GPP SA6. And over the last several years and several releases, we've been able to define the standards leveraging voice, video, and data communications for critical communication networks. And you see a lot of work that's also done at the level of ITU and regionally in many countries, as this becomes a very strong and emerging vertical for 5G and beyond. So my name is Suresh Chitturi, and I'm the current 3GPP SA6 chair and also the co-session chair. I'm also happy to be accompanied by Mr. Pranav Jha from IIT Bombay, who's a senior consultant at IIT Bombay and has a lot of research done in this space. So please welcome Mr. Pranav Jha as well as the session co-chair.
Thank you,
If you go to the next slide, so we have a great lineup today. We have 5 keynote speakers. We have Tero Pesonan from TCCA, who's going to be speaking about global landscape on critical communications. So welcome, Tero. And then we have Bill Yankee from FirstNet Authority of USA. So Bill also is going to be covering a keynote session on what FirstNet has been doing in their kind of vision or goal for broadband mission critical communications. And then we have 3 keynotes on the research track. Professor Gurither, a warm welcome to you from IIT Madras, who has been spending a lot of time and research in this space. So welcome, Professor Gurither. And also we have Sudeep Mishra, who will be talking to us about some of his work. Unfortunately, Professor Sudeep is not here, but we have a video recording of him. And then we have Ms. Debrati Sen, also doing a keynote for us based on UAV communications. So welcome, Ms. Debrati Sen. So followed by the keynote speakers or sessions, we also have a very exciting panel discussion with Professor Gurither, and we have Mr. K.K. Agrawal from Department of Telecom. Welcome, Mr. K.K. Agrawal. And we have Professor or Dr. Sekar, who's from Kerala SDMA, is currently in the Netherlands. So thank you, Dr. Sekar, for joining us. And then we have Tero on the panel as well. So this is the lineup that we have. It's going to be very exciting. So I just go to the next slide, Akash, if you can. Yeah, this is a quick look at the schedule. So it's a strict 2 hour 15 minutes, and we hope to wrap up on time. So after my introduction, we have, like I said, two keynotes under session 1 on global landscape, and then we have 3 keynotes on the research track, and then we conclude with a panel discussion for about 30 minutes with 4 panelists. So once again, welcome to this session, and I hope you sit back and enjoy to these conversations. And with this, we will start the first keynote. Akash, would you go to the next slide, please? Yeah, let me briefly introduce. So Tero Pasanen is going to be our first keynote speaker. Welcome again, Tero. So Tero has been, or is the chair of TCCA Critical Communications Broadband Group from 2024 onwards. He has been involved with professional mobile radio communication business since 1997, and over the years has acquired and developed deep understanding of the models to use public safety applications. Closely works with the major public safety and critical infrastructure providers and operators, and in creating advanced solutions to meet mission critical requirements. Tero holds Master of Science degrees in electrical engineering and in economics. So over to you, Tero. So can we show the presentation from Tero? Thank you.
Thank you very much, Urs. It's wonderful to be here today. In the next few minutes, I'm looking forward to cover basically, touch upon basically three topics. What are the core critical requirements in critical communications? What is the transition roadmap from narrowband to broadband globally? And then also touching a little bit, what are the, as this is about standardization, what are the aspirations for critical communications we have? And once we get the slides on, thank you very much. Maybe we can go already to the second slide, please. One back, thank you. Right, but before I go to those topics, a couple words about us. TCCA, we are one of the market representation partners in 3GPP, representing the critical communication sector, which comprises from public safety, PPDR, public protection and disaster relief, but also from transport, railways, utilities, mining, and all those sectors that use communication as a critical service. Our members are from industry, from users, from regulators, public safety, and dedicated operators, as well as commercial operators. And the way of working is very much on collaboration across the critical communication system, as well as based on volunteer contributions. So that's very short what we are. Have a look more on tcca.info, and please join us if you feel this is an important topic for you. Let's go to the next slide, please. So in the next few minutes, looking forward to cover what are the core critical communication requirements. Next slide, please. Let's start with coverage. Coverage is obviously the essence. If there's no coverage, there is really nothing. And here we have to be quite precise. What is coverage and what does it mean? On one side, in the metropolitan areas, it might mean valleys between high-rise buildings. It might mean underground car parks. And then on the other hand, on rural side, as we have the picture here from Finnish Lapland, we might be in the areas where there's basically nothing and nobody. But from critical communication point of view, the service still needs to be there. So in critical communications, coverage is more about geography than population. So coverage is the first requirement. Let's go forward. The second one is availability. In critical communication, in public safety, you cannot prepare for an incident to take place. It might happen at any time. It might be a natural disaster. It might be an explosion. It might be a robbery. It might be a car accident, and those may take place at any time. Therefore, also the communication system needs to be available 24/7, 365. There isn't really a very good time for service or other maintenance situations. So that was the second one, availability. Let's move forward. The third one, in addition to coverage, availability, is resilience. The service needs to be there in all circumstances. When it is a sunny, wonderful day at the side of a canal, but also when the weather hits and there's flooding. The service needs to be there to provide safety and security for the society, to enable the first responders to react in any incident. So this was the third requirement. Let's move on. The fourth one is performance. The performance needs to be there instantly. This means that when a person presses the press to talk button to speak in the group, before the sound comes out of the mouth, the connection needs to be there to deliver to the other end. In order to command and lead forces, all the information needs to be carried over. For instance, you can imagine a situation when the command is "don't shoot." What happens if the first word is not carried over? So it needs to provide instant service. It needs to provide performance in all situations, not only when the day is nice, not only when one is in urban area, but at all situations in all places. So the fourth one was performance. Let us move forward. And yet again, this has to scale. On one side, the operation might be a single lone worker working on a utility power station somewhere a long way from anything else, and the connection, the radio communication is the lifeline, is the only means of help and support. So the system needs to scale for one, but on the other hand, it might be Olympic Games, it might be national disaster, there might be thousands of people, citizens as well as first responders being in duty in a very dense area. So it needs to scale also up to massive. So from single to massive is the need for the scalability. And if we move forward, it most of all, having filled all the previous ones, it still has to be purpose fit. It needs to meet the requirements of the particular function persons are doing, be it someone working in a railway managing the security of a railway line, or it be it someone else in part of the Coast Guard or first responder, or in an ambulance providing care and service for a injured patient. The functionalities in the technology need to map into the present situation. So bringing this together in the next slide, in very shortly, these are the core critical communication requirements, more from the philosophical level: coverage, availability, resilience, performance, scalability, and functional suitability, because the connection is literally the lifeline in critical communication. That makes it critical, as it is the lifeline. So now we have set the scene for what is critical in critical communication. So let's move on and have a look how the transition roadmap looks from narrowband to broadband. Next slide, please. Thank you. Now, in TCCA, we have created this top-level PPDR, public protection disaster relief broadband roadmap. There are other roadmaps for utilities, for transport, for mining, and so on, but this is most of all now for public safety. If we look at the last couple of years, it has been mostly about standardization and implementation of those standards. There are some first movers in operation, mainly in dedicated networks in the Middle East area, but globally seen, there is very wide complementary use of broadband services for public safety. So basically, more or less in every country, as soon as there's a broadband service, 4G, 5G available, it is being used by public safety and other first responders in some way or fashion. Where we are right now is, again, standardization, but it in also very much what we see worldwide, we are in a phase of regulation. The question, how to then provide a mission critical broadband service to public safety agencies, not just best effort, but mission critical. How to get to that level? What is the constellation? What are the operational models? Should one need some dedicated spectrum? Who is allowed to do what? So regulation is a very, very big word there. In addition, there is a lot of work being done in concept building, in understanding what this broadband service actually is. How would one need to alter the current operational models from today's narrowband voice-centric services more to the information-centric services of the future. And indeed, gradually some services are being taken into use. Now, if we look at the rest of this decade, what we can see, standardization is going on. Well, let's face it, standardization continues until a technology is dead. So that will happen forever. But what we can expect quite largely is what are wide rollouts of mission critical broadband 4G, 5G services. We can also see that those services will be taken into use, and gradually users will be shifting over from their narrowband services to 4G, 5G services, mission critical services, and even utilize them as the sole service. And then what we will also see is brand new operational models development. We don't exactly know what those are, apart that we know that information is in the very core of them. If we looked at this on the timeline, that's on the next slide, please. What we can see is that Tetrapol P25, those services which are excellent for voice-centric services plus messaging, they will continue to exist. They will be still available beyond foreseeable future. If there is narrowband spectrum, those are the needs, those are just quite fine. However, if one needs to move into the information-centric services, utilize the benefit, for instance, of video, then the managed window for transition is just opening as the critical LTE is becoming available, let's say with 3GPP release 15/16. And here we can see that US, UK, and South Korea are pushing the envelope quite a lot there. If we look further down the decade, now in particular in Europe, the window of managed transition to broadband closes at the end of the decade. And this is because the current national public safety networks, Tetra, and Tetrapol, the base stations come to their technical end of life. So there, the time is either to reinvest or move into another technology. On railway side, the world is a bit grimmer than in public safety in that sense that they have to have moved basically before the end of decade, because there's an announcement that GSM-R technology will become obsolete at that point of time. Right, let's move forward and have a quick round the world tour. Yet another slide. please. Here we have the forerunners. You will be hearing about FirstNet just in a minute, so I won't say anything more about that. But UK was the forerunner in trying to move mission critical voice to broadband. Must say that started a little early, but we all have to be very thankful for them for the great effort they have been doing. Now the processing is ongoing and transition is happening. South Korea SafeNet, the rollout has taken place, so now it is in the situation of moving into use the national network. And in Finland, my home country, here we have the core network in place. We have the connection to commercial MNO, which provides preemptive priority service, providing 99% of the population coverage. Extensions required for geographical coverage to be in the equal level, and with the target that we would be in full operation with most of the users shifted over by 2025. Now, just quite quickly, the last part, what do we expect from 3GPP? Next slide, please. Quite surprisingly, focuses on those core requirements we had earlier. Coverage. All those things that can be done to make sure that there is a connection is a great interest for us. Secondly, we need to make sure that there is sufficient capacity in order not to end up in a congestion, not end up in the situation where we cannot operate anymore or there isn't service available. And thirdly, there are a couple other things in terms of location, which is very important to know where your units are, what their state is, as it is also a security issue for them, plus a couple others. So quite shortly, those are the kind of things we expect to have. Next slide, please. Just saying that this discussion, if you need to know more and in more precisely what all these things are, there is this critical communication world event starting next week on Wednesday. It's virtual as well as a person event, so join there. I'd like to recommend that. And with that, I come to my summary. Next slide, please. Pulling all this together, so the connection is the lifeline. So it needs to be there with the requirements. Secondly, national PPDR systems are moving to 4G, 5G transition. That happens during this decade, most of all in Europe, but also in other places. And thirdly, the focus why we work so much with 3GPP is that the only way we see forward is with open standards. Thank you very much.
Thank you, Tero. Excellent presentation and helping us walk through what's happening globally and what you are doing as TCCA. I do not see any questions, I believe. But yes,
there are no questions. Yes.
Yeah. Thank you, Pranav. Yeah, so there is actually one quick question, maybe for this session. So the speaker is from Ericsson, or the questioner is from Ericsson. So the question is, though standardization is ongoing, can you share a few challenges from operations perspective for critical comms? Tero, do you want to take this?
Either now or perhaps we discuss this more during the panel session, because I think this is a rather large question to be answered.
Okay, perfect. So thanks once again, Tero, and for keeping up the time. So we're good. So let's go to the next keynote speaker. This is Bill Yankee, who's a senior standards engineer working on mission critical standards development for FirstNet Authority, which is the organization in the US that is responsible for mission critical communications. So Bill has a tremendous years of experience, over 40 years. He's seen it all, right from legacy technologies like P25 and moving into broadband critical communications. He's been a very active participant and contributor to 3GPP standards as well. He has a bachelor's degree in engineering physics from University of Illinois, where he was a bronze tablet scholar, and a master's in electrical engineering from Syracuse University. He also has an advanced course from GE in engineering, which he has worked briefly in his career as well. So welcome, Bill. Over to you.
Thank you, and that was all a long time ago. Good afternoon, everyone. I think afternoon, evening over there. It's morning here in Virginia in the USA. I'm going to give an overview of FirstNet and what our vision is, how FirstNet came to be, some of the information on some of our network deployment. Go ahead to the next slide, please. And then hopefully tie it all together at the end with how standards play into FirstNet. So this is just our agenda. So go ahead, let's get right into it. Thank you. So it may be hard to believe, but last month we celebrated is not the right word, but we recognized the 20th anniversary of the 9/11 terrorist attacks in New York City and in other places in the U.S. And those attacks kind of highlighted some of the communication challenges that first responders face, particularly during emergencies and disaster situations. So the graphics here show a timeline. It's been a long time, but we're making great progress now. And as you can see here, we spent a few years studying the problems, and there was a 9/11 Commission report, and then public safety agencies lobbied very hard they had a vision for a nationwide network, and they lobbied hard. And finally, in 2012, through an act of Congress, there was the FirstNet Authority was established. And FirstNet stands for First Responder Network. So the FirstNet Authority was established in 2012, and since then we have been working to establish contracts and deploy the network, and talking, of course, to our constituents. We interact frequently with public safety agencies to get their feedback on everything, what they need, and how our deployment is going. So let's go on to the next slide, please. So how is this all organized? FirstNet is a public-private partnership. We are an independent entity under the U.S. Department of Commerce, and we established a partnership with AT&T via contract in 2016, I think, and the contract lasts 25 years. I won't be around to see the end of the contract, but we're in the middle of it now, and you can see the division of responsibilities here. We mainly have oversight and public safety advocacy, so we are kind of the conduit between AT&T and the public safety first responder users and agencies that are signing up to use FirstNet, where AT&T has responsibility for the nationwide deployment, the RAN build out, customer care, and many other things like that. And finally, we also represent the United States in standards for public safety. So FirstNet takes the lead on mission critical standards development for first responders and mission critical communications. Of course, we work with our public safety partners around the world, like Taro and many other countries, also represented in the global standards bodies, particularly 3GPP. And we work with AT&T, who has a very strong standards team, and they advocate for us in standards when we need it. So next slide, please. So this is just a quick overview of what our vision is. It really consists of three main parts. As I said, we engage with public safety regularly. We have an advocacy team that meets with public safety all around the country and get their feedback on what kind of features they need and how the network deployment is going and devices and other things like that. We have a roadmap that it's a technology roadmap. We have written that down and published that, and it is available, and I'll tell you where in a minute. It kind of sets out our vision, and then finally, as you may not know, so we own the spectrum. So we manage the spectrum, and we basically loan that back to AT&T and say, here, you can use the spectrum for your public safety, for anybody, for commercial users, but you have to give public safety priority when they need it. And that priority even includes kicking everyone off our particular band of spectrum in case of disaster or emergency. Now, because they get to use the spectrum, they give us regular payments for that usage. We take that money and we reinvest it back into the network. And in many cases, the money that we use perhaps is to drive technology that may not come to fruition because the public safety market is fairly small. So as you know, there's billions of people that want to use cell phones, but not so many people that want to be a public safety first responder. So with a small market like that, sometimes it's very difficult to justify for companies to go out and invest and create products that the public safety needs. So our plan is to reinvest a lot of our money back into technology development if we can. Go ahead to the next slide, please. So this just briefly summarizes what I just said. We create a long-term vision, we engage with public safety, and then we make investments to achieve that vision. So one example of an investment that we've made recently, the original contract in 2016 was for LTE only, 4G. But as you know, nationwide deployment takes a long time, and technology evolves. And if we want to evolve with it, we need to reinvest back in the network. So now we have an upgrade to our contract with AT&T to move to 5G. So that's an example of how we're using our investment dollars to feed back into our network and to continue to evolve technology as we move along. Next slide, please. I think maybe it was on the previous slide, but that's okay. The roadmap that I talked about is available at firstnet.gov/roadmap. So you'll be able to go and download that document and can read about what we're doing as far as our vision. And this slide shows our roadmap priorities. We have 6 main areas that we focus on. And within each of those areas, there are particular technology areas of focus. As you can see under core and coverage and capacity, all the different technology focus areas that we have. We also have situational awareness, voice communications, secure information exchange, and user experience. There's many exciting things coming along in user experience. And as you may know, the challenges of first responders, when it's just voice communications, they're very used to having that hand-eye, ear-to-eye coordination and being able to use your devices. It's not too complicated, but when you start adding messaging and video and all sorts of other things, we really need advances in user experience so that you can take advantage of the broadband services, but at the same time, you're still able to do your job under a very high pressure situation, which is what first responders are under during emergencies and disasters. Go ahead to the next slide. So the FirstNet network it's a bit more than nationwide. We have 50 states here in the United States. We also have 5 territories, and then the District of Columbia, which is essentially Washington, D.C. We have federal users, state users, tribal users, and then local agencies. And there's, 60,000 maybe public safety agencies in the United States. So I think is similar to India in some respects as how we're organized at the federal level and then individual states. So the build out is somewhat complicated, as you might guess, and it's been a long story. The first thing we did was we had to go out and engage with all of the public safety agencies, not all 60,000 of them, but we interacted at a state level. And we had to get the buy-in because the legislation said that you don't actually have to connect to FirstNet if you don't want to. But luckily, we did a good job selling it. So everyone signed up, all 50 states, all territories signed up to opt in, what we call it. They opted in to use the network. So go on to the next slide, please. So this gives a snapshot of where we are today, or maybe a few months ago. I'm not sure. It changes every day, but as you can see, the build-out status is pretty impressive. We have over 2.5 million connections now. We have 17,000 public safety agencies have subscribed to FirstNet. We're building out our coverage, and I'm not sure whether I didn't explain this properly, but one of the I think that's coming on the next slide, so we'll wait a minute. So anyway, we have applications, we have devices, we have deployables, which is a big part of our network. When there's a disaster, and sites get knocked down, you need to have deployables, and we have lots of different options for those. So we're doing pretty well. Things are moving along, but we still have a long way to go. So next slide, please. Yeah, so this is what I wanted to describe on the previous slide. What was our build out strategy? So one of the advantages of the public-private partnership is to be able to leverage our partner to get coverage and get coverage quickly. So AT&T was kind enough to allow public safety to use all of their bands and give them priority. Now, as part of the legislation in 2012, we were given ownership of band 14. So that is for exclusive use of FirstNet if we need it. But as I said, AT&T can also use band 14. So as we build this out, we started off using the existing AT&T coverage, which was nationwide. And then we're adding band 14 to those existing towers. So now we have new spectrum to use, and AT&T can use it as well. But then we also have to start putting band 14 and new cell sites into every state and territory. So one of the problems with public safety, of course, is they need to cover where people may not want to be. You know, if there's a disaster somewhere in the middle of nowhere and there's no cell sites there, what are you going to do? You either have to have deployables or add more sites. So every state that we interacted with, we came up with a coverage plan to say, okay, we're going to give you this much coverage in the state. This is how much we're deficient, and we're going to add sites in this area. So all those new sites are basically band 14 sites, and that deployment is going along very well, but we're still in year 3 or 4 of a 5-year plan. So we're not quite done with that deployment of all band 14 and making the coverage acceptable to each of the individual states that opted into FirstNet. It's a little bit complicated, but essentially we hit the ground running with AT&T, and now we're filling in coverage as we go along with new band 14 sites. So go ahead to the next slide. So as you know, even adding sites, no network can economically cover everywhere. So we supplement coverage with fleets of deployables. They can be sent to the field as needed. Primarily, they're used when cell sites are destroyed by hurricanes or tornadoes or even bombings. We had a bombing in Nashville, Tennessee last Christmas, and that was knocked out a bunch of sites. So, but they can also be sent to remote areas where we don't have any coverage in case there's an issue there. So we have a large fleet of deployables to use. Go ahead to the next slide, please. So AT&T and FirstNet continue to innovate. I talked about our investment strategy, and this is just a quick example of some of the new solutions that we're deploying in the network. We have what we call FirstNet Mega Range, which is the high power UE. Z-axis is a critical feature that people have been asking for decades, particularly firefighters. We have a compact rapid deployable that AT&T just designed and built that a single person can deploy it in a matter of minutes. And then of course we're using FirstNet push to talk and experimenting with that and starting to deploy that around our network. We'll get to that in a second. So go ahead to the next slide, please. So push to talk, of course, that is one of the primary things that everybody talks about in mission critical communications. That's what legacy Lmr does for a living, and trying to replace that is pretty challenging, but we're moving forward. And some of you may be familiar with our first deployment, which was a push-to-talk solution, MCPTT, Mission Critical Push-to-Talk, if you're familiar with the 3GPP standards, from Samsung. And it comes with some great devices, and we're starting to deploy that around our network, and people are using it and starting to experiment with it. We're not replacing LMR yet. It's not quite ready for that, but it is not just an over-the-top product. It's actually built to the standards designed by, created by 3GPP, and is integrated into the network. So it has priority, quality of service, all those things that you expect. So go ahead to the next slide. So I'm probably getting close to running out of time, so I'm not going to go into great detail about this slide, but just suffice it to say that we have a lot of applications, 181 in our catalog, and we have 282 devices on a list that's kept by the National Institute of Standards. Each of the applications and devices have to be certified in order to be available for public safety. Of course, for a device, one of the certification steps is to make sure it does band 14, which is our primary band. But the applications also have to jump through hoops and make sure that they are secure and all that kind of stuff. So we have a lot of applications, a lot of devices to choose from, and more every day. So go ahead to the final slide, I think. Okay, so just briefly, how do we tie all this together with standards? So standards, of course, are critical to FirstNet. It was in the legislation that we had to be built to standards. We had to use commercial standards. We had to use LTE, actually was in the legislation and in our original contract. Of course, we're evolving that, as I said, we're moving to 5G. So we work hard to ensure the standards are followed as long as the standard exists. And if there are gaps, we go back to the standards bodies and work on that. Of course, before FirstNet was created, there was a lot of work that had already been done in the standards. Mission critical services in 3GPP were started back in 2012, 13, and 14. And the first cuts of those were finished almost around the same time we were signing our contract with AT&T. So anyway, what we try to do is we take our roadmap, and these are the same 6 areas that we talked about that I talked about in our roadmap vision document. And then we look at in each area what are our highest priority items to focus on in the standards area. Of course, in general, one of the advantages of leveraging commercial services and partnering with AT&T is that we get a lot of innovations for free. Every release has higher bandwidth, lower latency, higher reliability, better battery life. All those things we can take advantage of without really doing much, because those are things that everybody needs, and even the commercial operators are heavily focused on improving those things. So that's one of the great things of having this public-private partnership and leveraging commercial services. But there are some things that are mission critical specific. And as Suresh said, we have in SA6, we focus on mission critical services, and we look at the 3 main services are push to talk, video, and data. We also do interworking. It's very important for us to interwork with legacy LMR, because as you deploy your network, you can't just turn a switch and switch from legacy LMR to broadband communications overnight. You have to keep your services going, protect the public, keep everything running, and at the same time start using broadband and moving that along. So most of our users today are actually using FirstNet for data services, mobile data terminals in their vehicles, other types of data services, and that FirstNet brings along, the dedicated spectrum, priority, quality of service. So they're switching over their data services to our network, and now starting to deploy things like mission critical push to talk, video, and data. So as you see here, as Tero said, coverage is king. So without coverage, you really have nothing. So we're always focused on new coverage solutions. Proximity services is one of the things that has garnered a lot of attention for us. Direct mode communications, off network, public safety. Even though you can cover wherever you as much as you can, and you can have deployables, but you're still going to have situations where you have no coverage and you need to communicate. So proximity services or direct mode, side link is another term that's used. That's very important to us. And another one, we call these enablers. They're not really mission critical services, but they're enablers that we use. The other critical one is multicast broadcast. That started off with EMBMS and LTE. And these are, this is a solution for, let's say you have an incident and 1,000 first responders show up and they're all in a small area and they all want to do video or they all want to talk at the same time. It's really very difficult to handle the critical disaster situations with just unicast. So MBMS and 5 MBS for 5G is another critical enabler that we focus on. So anyway, I think I've talked about a lot of this, but you can see here, if you go and download our roadmap, you can see a lot of the focus areas that we have, and then you can start to understand how we tie that back into standards and where we go to focus our efforts in standards. And I think, you know, just to wrap up, I think the future is here. We're deploying, we're using it, but there's still a long way to go and a lot of exciting things coming. So that concludes my presentation. Thank you.
Thank you, Bill, for the excellent presentation. And I have to say, being in this sort of area myself, FirstNet, is a real blueprint for many countries on how a country can kind of absorb the standards and develop solutions for the needs of the first responders. So thank you for your presentation and all your work at FirstNet. I have a question that has come up. Could you talk more about Flying Cow, specifically coverage, range, frequency band, and list of services it provides? If you can answer this.
Okay, well, that's
Maybe
easy.
briefly.
So the Flying Cow is just a cell on wheels. So you know that there are many solutions that commercial cellular has for large events. They'll bring in what they call cows, cells on wheels normally. They'll drive a truck in that has additional cell sites on them or a cell site, and that automatically gets integrated into the network with self-organizing network technology and that those kind of things. And it normally connects right back into the network and looks like a new cell site, and everything works beautifully. The Flying Cow is just the same thing, except it flies. So let's say you have a hurricane that comes through and all the cell sites are knocked down. And maybe the roads are blocked. You can't even bring a cell on wheels into the area. So we have a dirigible and some other solutions. Probably drones are coming, that cell sites on drones, but essentially they do the same thing. They bring a cell site, they put it up in the air now with a drone or a dirigible. Normally it's backhauled with satellite and or maybe it's just a standalone site. It just depends on what you have available and what's in the deployable. But if you're backhauled with satellite, then all the services that you're used to are available. If it's just a standalone cell site, you might just be able to do communication, whatever it has on board. There's various solutions for that. And I think there was a question about frequency. Band 14 is our spectrum, and that's in the upper 700 megahertz band. So it's 10 megahertz up and 10 megahertz down, so 20 megahertz total. And, the deployables have various frequency bands. Some of them are band 14 only, but most of them support all of the AT&T bands as well.
Okay.
Can I answer that question?
Yeah, thanks, Bill. There's one more question, but in the interest of time, we have to move on. But I will still read out the question. What are the major differences between Lmr and Hc Dmr? Is it possible to merge these two services in the broadband version of the mission critical communication? I don't know if you want to maybe take a quick shot at it, but it's another question that has come up. What are the differences, and can it be merged into broadband version?
So can the legacy LMR be merged with broadband? Is that the question?
I mean, the differences in LMR and Hc Dmr, and the second part is can this be merged?
Oh, DMR. Geez, I don't know a lot about DMR, but DMR is kind of a commercial version of push to talk communication. You know, the legacy
Bill, should I
LMR.
take it?
Yeah, go ahead, Tero.
Well,
Thank you.
obviously, first of all, obviously, LMR is an umbrella term for land mobile radio, which means the same as PMR, professional mobile radio. DMR is one of these technologies under this umbrella. And yes, indeed, in 3GPP, we are working a lot to make a solution in broadband, which provides the services for all these technologies in broadband area. But in that sense, one cannot really compare LMR and Hc Dmr because LMR is an umbrella expression.
Okay, thanks, Tero, and once again, thanks, Bill. So let's move to the next keynote.
Excuse me, one question from Mr. Will to Mr. Will. Hello.
Yeah, go ahead, Mr.
Yeah,
Agarwal.
I am taking all this. Yeah, it's regarding this FastNet, which is being implemented in US. I want to know what is the funding model. I mean, it is totally funded by government, or as you are saying that it is in PPP model, so some private participation is there. And what is the utilization of this network during peace time? And second question is regarding rollout status, whether the FastNet is uh, rolled out only on coastal areas, border areas, or all across the US, or they have shared the network with other telcos in US, and only a skeleton network they have deployed. So just I want information on this.
Bill.
Okay, very quickly, because I think we're running over time, but yeah, I think I got most of the question. It was hard to hear everything, but first of all, on the funding model, I think was one of the questions. The legislation in 2012 established FirstNet, but also allocated $5 or $6 billion to build out the network. Now, of course, to build out a new network from scratch probably would cost you $30 billion or $40 billion. So it was not enough money, but it was enough money to attract the attention of someone like AT&T or Verizon. They both bid on the contract, and AT&T won, as is now our partner. So they get that money. We gave them money to help with the build out part of the $5 billion. But then at that point on, they give us money back based on using our spectrum. So we are funded completely by the money that we get back from AT&T for their use of our spectrum, and then in return they get the additional spectrum for their commercial users, but then they have to give us priority and quality of service on the network. As far as the deployment goes, yes, it's a nationwide deployment. It covers everywhere that AT&T covers plus more. All the existing coverage, which is probably 95, 96% nationwide, something like that, by AT&T, and then we fill in as each of our states require additional fill-in coverage. So it is nationwide. There was a third part of the question. I don't think I got it.
I believe you covered the questions, Bill.
Okay.
But what I can do is perhaps enable conversation offline. Mr. Agarwal, if you have more questions, I can help you with that.
Sure. My contact information is at the end there, and feel free to send me emails. No problem.
Yeah. All right. So let's move on to the next keynote. So the next keynote is by Professor Gurither. We're moving into the research track now, and Professor Gurither, I hope your connection is okay. I saw your drop off briefly and then back on, but I hope it's fine.
Yeah, I'm fine.
Okay, excellent. So, Akash, would you be able to display the slide?
Oh, can I share my screen? That will be a little bit better.
Yeah, you can share your screen, but I just want to introduce you. But
Yeah, go
again,
ahead.
I can do it off just with my own local copy, and then you can share yourself your presentation. So let me welcome and introduce Professor Gurither. He's a professor of electrical engineering at IIT Madras, a premier institute in India. His research interests are in the areas of adaptive signal processing and wireless communications, and he guides the telecom and wireless sensing research group at IIT Madras. Professor Gurither has been a consultant for many telecom and signal processing organizations and research labs in India. He's also been on sabbaticals to various organizations like Gigabit Communications in San Jose, BCom Communications in Santa Clara, and so on. He's also the visiting faculty at Sri Satya Sai Institute of Higher Learning, and also at Stanford University in California. He has received his master's degree from ISC Bangalore and PhD from University of California, Santa Barbara. Thank you for joining us, Professor Gurither, and I think floor is yours. You can display the presentation by yourself. Welcome.
Thank you. Thank you, Suresh. Prakash. You see my screen now?
Yes, we can see it. Thank you.
So before I start, I think I really enjoyed both Mr. Prasannan and Ak's presentation. A lot of things I didn't know about critical communication. Here, of course, there are quite a few questions. So maybe essay 6 declare some of these would get answered. Hopefully, some of us got. So that let me take a minute on what I see as what kind of critical communications can be configured for 5G NR. In my perception, where are the gaps? Little bit maybe the Indian perspective. So critical communication must imply 95% geographical coverage. And this is something I have been, implicitly thinking of for nearly 5-6 years, and I never knew that it has been formalized into the mantra what even, TCCA and others say. And so this notion of switching over from user coverage to geographical coverage is absolutely vital. But can we do this? This kind of ubiquitous coverage can be given with bitrate guarantees, right? I think that's the for example, can I give 5 Mbps everywhere on the downlink and 3 Mbps everywhere on the uplink, while I give 95% geographical? I think this is critical for multiple use cases, not just first responder, right? This for education, for health, and so on. And this is a vision what countries like India should have. And the notion of disaster resilient network infrastructure again is extremely well taken. And yes, during situations where there is a natural calamity or man-made calamity, there can be some graceful degradation in rate, but not in coverage. I think this is absolutely well taken, and I'm happy to note that the first speaker was saying exactly the same thing. But I want to push it forward. Even when multiple, let's say, E-node Bs or towers or access points fail, even then, you should have the coverage available to you. So how do you do? And critical communication should get us there. And thirdly, as many of us been thinking about, there should be a seamless way that you can add bandwidth on demand. So you can add more nodes, radio on the move. It could be a terrestrial node. It can be, for example, a truck is driven there and you erect towers and give coverage, or it can be on UAV platforms, right? Either a cow, calf, horse, pig, anything you want to fly, that's fine. But you need to. So the point is, At least in my conception, these three were the main thing. And how will this be driven, right? And that's the one issue. But once we do this, it's a side effect, right? Because, and I'm sure this experience, many of you might feel, I have talked to people in various countries. Today, truly ubiquitous coverage we don't get even in our 4G network. Or even in 2G perhaps we get, but not 4G. So, and once we get this kind of coverage, we'll get rural broadband. We'll be able to actually address digital divide in a wholesome manner. We will now move on to perhaps broadband IoT, narrowband IoT. And this can suddenly increase the business opportunities for people living in rural areas. And finally, the other side effect, which is very important, is that there are several coverage holes for reasonable quality, even texting. Forget data or forget voice, right? Even in big cities. So can we get rid of coverage holes? Some countries have done this. I'm sure South Korea has done it well. Perhaps Singapore has done it. Perhaps Sweden and Helsinki have done it. But whether it's there in every country, I doubt it. So I talk to many people, especially people in the what can I say, towards the equator, right? Where a lot of precipitation happens. We find that in many of our cities, there's the lots and lots of coverage. So even though there are every operator has been about 5,000 towers. So support for critical communication in 5G NR. Yes, we are aware that 5G NR has taken some steps to go beyond LTE. There is bandwidth partition, the notion of bandwidth partition, where you can change the numerology and then you can create a own network slice. In a way, this gives flexibility to even perhaps look at. I remember, I think, person said everything should be standardized at a global level, but once you standardize the bells and whistles, and the actual network slice itself could be made. I mean, there could be a particular requirement in India which may not be there in Finland. So the fact that there is this multi-numerology and other things available in the standard allows us to actually have applications which are, they are still standardized in a way, but we could go and deploy things which are very different country to country. It's really a big advantage. The explicit support for ultra-reliable low latency, yes, we exploit it. There is carrier aggregation and multi-band support, including 5G NR in the lower UHF bands. And as a group, we have spent a lot of time focusing on how to utilize the sub-1 UHF band well. And in that context, I got interested in grid communication as well as basic access net. How do we build out in the sub-1 GHz band, right? And I think there is a big opportunity here which we should take. The question is, standards have all these, but does it automatically guarantee support for the three things we said? Does if I take 5G NR and I build a critical communication network, it will be ubiquitous with minimum bitrate guarantees and so on and so forth. Will it, I think Personan had a 5 or 6 point charter for what a critical network should have. We satisfy all that. That's a big ask. And the key question, and I could see that also being alluded to in the question what was asking earlier, would critical communication support and wireless standard be driven by business needs or by regulation or by policy or by legislation? Which will drive it? If it's going to be driven by business needs, it will happen earlier. We all know that. It's going to be driven by legislation. It may happen in some countries, it may not happen in some, right? So this is something which one has to look at. I'm just taking two case studies of what we have looked at, more in the context of 4G, but a little bit in the context of maybe 5G and others. And I'll just share them with you. So the first case study is a deployment for ubiquitous coverage, sub-1 gigahertz band. And what would be the issue when you try to do this for critical communication? The second case study would be a disaster-resilient cellular technology in sub-1 gigahertz bands. So what does it take to do this? Right? One idea which I'm going to share. So let's look at deployment in sub-1 gigahertz bands. What would be the issue? So if you look at case LTE or 4G NR, right? Let's compare the deployment at 3.3 gigahertz service, let's say 450 to 700 hertz. So at 3.3, you are going to see, right? Let's assume a particular region where you covers, and you'll see some coverage, but then there will be noise limited coverage hopes, meaning in these locations, just because of lack of signal power, you will not be able to support the adequate rate. See, we are talking about supporting critical community, not just as I said, first response, but we are looking at supporting education, e-health, a few other applications which would need minimum bitrate guarantee, right? In the order of few megabits, not kilobits. And so you will have now noise limited coverage codes here, where you may be able to do texting, but can't get any remote learning or work from home can't be done. Now the same you deploy in 500 megahertz LTE, now you will get much wider geographical coverage. We all know that, because right away you get about 1780 dB extra link margin just by changing the band. But then what would happen is, the way LTE assumes, right, it can do spatial filtering and it can move on interferer. That won't happen in these bands because of the spatial correlation. And so you'll get interference limited coverage. So current LTE release 12, release 13 cannot get rid of these holes. So you get good signal power here, but you get interference which will hurt your SINR, and this is the issue. And if you look at the way 5G NR, at least up to release 16, they have no other way to manage this as well. So the standards are essentially, they try to manage interference which are happening within multi-user MIMO streams, for example. So inter-antenna interference, inter-sector interference happening within the same sector of the same tower, that there are ways to handle it. But when you look at inter-tower interference, right, the standards are still very weak, especially when you come to the lower bands, right? And this is one of our focus areas for the last 7-8 years. So we have tried to understand how to deploy networks with overlapping coverage, because one of the things which you need to do critical communication, one of the requirements should also be to do user localization. So unless you have overlapping coverage, user localization becomes more difficult for emergency services to reach. And the point is, how do you therefore work with interference limited coverage holes and give good rates while you take care of some of the other needs for critical communication. Now, if you look at typical LTE to manage, or even 5G NR, to manage interference due to overlapping coverage, they would use some kind of frequency reuse, could be fractional frequency reuse. We call it loading. So the number of subcarriers we load over the air interface could be lower, but that will take away your spectral efficiency, right? And you could then, the other way to look at what 5G NR would like to do more in the lower bands is to use it for supporting narrowband IoT or machine to machine rather than basic access. But in countries like India, we are looking at using these bands for basic access, reliable basic access with minimum bitrate guarantees. So one of the holes I perceive in 5G NR is there's not adequate support for interference mitigation in the sub-1 gigahertz bands, especially in the context of providing basic access. See, if you're looking at narrowband IoT, the instances where interference would occur will be much less, and even in M2M, right, you're looking at much lower bitrate links, so you can get away with this kind of interference, but not when you're trying to provide sustained bit rates in the order of a few megabits to users. Disaster resilient wireless infra. So this is another area where countries like India should look at very carefully. There has been a lot of promises, but none have been delivered to the country. We see this repeatedly when there is flooding happening or landslides happening. I'm just giving you one example of what we studied. This is about 4 or 5 years back we did this work. What we conceived is that instead of these different towers belong to different operators. So we have been working on multi-operator spectrum sharing. They share the same spectrum, but unlike license spectrum sharing, what Qualcomm and Ericsson have been proposing, here they share the spectrum simultaneously. It's mandated that they share it simultaneously, not in some orthogonal manner. And one advantage of such sharing is that you can now look at getting rid of coverage holes, as well as giving very, very high bitrate, highly reliable BPDR services. So this is a study we did. This is a work we published in ICC in 2017. Just to cut the long story short, on the left-hand side, all the infra is available across all the operators. The curve, this is a SINR CDF curve. So the more right the curve is, the better it is for you in terms of coverage and so on. So if you see a single operator deployment, this is a curve you get. But for a multi-operator deployment, the curve is 10 dB to the right. That means you can now penetrate maybe a couple of more walls in the context when a user can connect to any operator. And then these operators share, the PPDR services are shared across operators. Now, what is striking is that once some of the infra collapse, in this example, 50% of the towers have collapsed randomly. It could belong to any of the operators. They lose some of the infra due to whatever flooding, power outage, landslides, so many things. Now, what happens is that the CCDF curves will, the CDF curves will shift to the left. So now what happens is that you are left with poorer coverage, but yet when there's a multi-operator spectrum sharing happening, the gap actually increases. In other words, when infrastructure collapses, when operators are sharing the spectrum, you get a bigger benefit with respect to a single operator network. So this is a reason why you should share spectrum. And if spectrum is shared, spectrum cost can be made lower, and even the government will benefit. So just to conclude, would 5G NR evolution address ubiquitous and disaster resilient coverage? Hopefully. So we have been working on orthogonal, non-orthogonal spectrum sharing in the sub-1 GHz bands. And what we really believe is that the time has come not only to use it for critical communication along with other applications, which I don't have time to explain now, but I think along with telecom, we can look at other safety and security applications which can be sitting on the tower, right, which can also be added. And this expands the ambit of critical communications or critical infrastructure. Thank you.
Thank you very much, Professor Gurither. I think very interesting research, aspects that you have brought up. Being in the standards, we don't look at it so closely as you do, and there's a, I think this is very helpful, and particularly your case studies are very interesting.
Thank you.
I hope those can be taken into account as well here in India and globally. And now I would like to, I don't see specific questions for this session. There is one question, probably it's a more general question. We could probably take it at the panel, which is there a standard on greater than 95% geographical coverage other than attributes you have mentioned. So I believe, is there, yeah, is there a standard? Let me repeat. Is there a standard on greater than 95% geographical coverage, um, or other attributes that you have mentioned? So my reaction to this is, I think, based on what Bill from FirstNet and Tero has explained, large part of this is how you deploy things. But perhaps Professor Gurither, this has some connection to your research, where by leveraging this multi-operator spectrum sharing could enable us. Maybe it becomes a de facto standard. I don't know, but yeah. If you want to respond, please feel free to, or we could move on.
Yeah, I mean, we have been putting this down as 95% and not 98% or something, just to be more practical. But the caveat, what we wanted in was the fact that you should get this kind of coverage with minimum bitrate guarantee. So even Prasannan talked about the migration from narrowband to broadband. So we wanted this with, let's say, a minimum uplink downlink rates of, right, and this is more in also, we keep hearing, and this is something which is an open question. We talk about LTE availability in India, for example, of 95%. And I used to wonder, what is the real meaning? How did they measure LTE availability, right? And this could be just based on user coverage. Wherever there are users and wherever they have smartphones or whatever in a particular kind of equipment, they have measured LTE availability. But have they measured it for some sustained bit rates or for any bit rate? So we need to standardize that, and as a country, we need to have a number which we need to ensure, and we have to also have ways to do drive tests to figure out that the operators who are getting the spectrum at lower cost in order to meet these numbers, they actually meet those numbers, right? And this is an open discussion we could have. But I want to also understand how, in the US or in Finland, how do they ensure that these critical communication needs are met? Even if I say 95% geographical coverage, how are you going to ensure it is actually 95%? Or these are open questions. I'd like to hear from others.
Yeah, but I agree. And Tero and Bill, if you're online, do you have anything to add on this in terms of how you measure the coverage of 95%? Geographical coverage. Yeah.
Absolutely. Well, in the Finnish case, we have our landmass, which is about 340,000 square kilometers. So in other words, I think it's about a bit less than the state of Rajasthan in India. And we have currently the narrowband network there, where we know exactly what the coverage of that is. And that is currently 99.2% of the geographical coverage, excluding some of the maritime territory. And now for the broadband side, we have in our contract that the MNO partner will provide us the same coverage as we have in narrowband. Now again, you're absolutely right. What does it mean to have coverage? And that is then a per case decision what kind of service level you have at a certain point from where the coverage is calculated. In our case it is, if I remember right, it is 10 megabits uplink and 10 megabits downlink with a certain signal strength that is measured with the radio at an elbow level, I think it was, or a hip level, I'm not quite sure. And that is then the measurement factor for judging whether something is still in the coverage or not. So that is then the formula for broadband coverage in theory, and in practice the similar fashion as in UK. The devices are and will have tools to provide signal strength and performance criteria as they're being used in order to provide live measurement from the network to compare whether the coverage is actually what the theory says it should be. So those are the means there. Maybe a quick comment. In our case, this is our requirement because we already had that coverage, and we have very long border areas towards Russia, which is the key border between European Union and Russia, resulting that we have a high interest in providing critical communication services in those areas. In some other nations where you have, say, very high mountainous regions, say in Himalayas, it really doesn't make sense to provide coverage in places where there's absolutely nobody from a terrestrial network, from a cellular network. Then other means make much more sense and are more feasible to maintain and operate. So 95% geographical coverage makes sense in those areas where it actually makes sense.
Absolutely. So, quick question to you: 10 plus 10 are able to achieve in how much percentage of Finland, right?
Well, that is the expectation that is to be reached basic in practice everywhere in the nation where there are any incidents on the 10 megabits per second up and down is the expectation pretty much everywhere in the nation. Whereas then as you are closer to base station, your service level is expected to be much higher. The maybe speciality we have is that public safety has preemptive priority on every frequency band of the supplier on every technology they have, although we are only interested in 4G and 5G technologies. But that means that the frequency spectrum the provider has is quite significant in very many areas.
Great, thank you.
All right. So I don't know, Bill, you want to add anything? Let's move on. Otherwise.
I would second what Tero said. It's very similar in FirstNet. Of course, as you know, broadband is a lot more complicated to figure out what your coverage is. In legacy LMR, we would do a voice quality test, or in some cases, if we could get away with it, just a signal level test. But broadband is a lot more complicated. But same issues and same kind of guidelines as what Tero just said. Thanks.
Thanks, Bill. Now let's move on to the next keynote. We have Professor Sudeep Mishra's session, but he's not available and we have a recorded session. So I was wondering if Ms. Debrati Sen, could you go next and then we keep the recorded after you?
Sure, Suresh.
Yeah,
sure.
that way we keep some continuity. So let me introduce everyone to Debrati Sen. She's from IIT Kharagpur and she's an associate professor there. She has a postdoctoral research from CUT Sweden and has worked with Samsung Research prior to that. She's also a student from IIT Kharagpur, she joined IIT Kharagpur after her work, and visiting faculty at TUM Germany, and also an academic visitor at Monash University, Australia. She has a lot of research in wireless and optical communications, several patents, as you can see, and more than 100 papers in journals and conferences. So we're delighted to have you, Ms. Debrati Sen. So over to you. I think you have an exciting topic.
Suresh, can I share my screen?
Yeah, sure, of course. You can do that. Are you able to? Yeah, you can do that yourself by clicking the upload button. Yeah, perfect. We can see you. And I hope we can see the presentation soon.
Can you see my screen now?
Yes, we can. Perfect. It's in the presentation mode, so please go ahead.
Today I will try to focus on actually deploying the UAV assisted network for the disaster management, and also we'll talk about how the synchronization is going to establish for establishing such kind of the network, how synchronization becomes a very critical, mission critical issues for deploying such swarm of the network. And then I will be also trying to highlight upon the another important issue about the last minute backup creation from a network which is going to be totally damaged under the disaster. So these are some of the very recent events we have seen in India and around. And these days, basically, the natural disasters in Himalayan range, as well as actually due to the over rainfall in India, has come in a number of the cases. When such kind of the things happen, you face three different problems. First of all, is there any mechanism can be provided where you will get an early warning system? So you need to develop some kind of the app maybe, which will be connected to the service providers, to the rescue team, to the telecom operators, so that all of them will be initially given the information about the upcoming event. And then once a disaster, you know that the disaster is coming, for example, if it is an earthquake, you will get a 3 minutes kind of the time gap between the first wave comes and the second wave is about to hit. So you understand that within this last 3 minutes, so whether you can take a backup from the hotel communication network where the disaster is expected to happen. And the third important job that is there in our hand is to actually deploy the network after disaster as fast as possible. Because we understand that the first few moments, first few minutes, and after the disaster happens, a couple of minutes are the golden period for relief time. And to actually, you can really provide the lifeline. Somebody was stating that it is connection is a lifeline for the critical communication. You should be fastly deploying the network so that you can establish this lifeline as fast as possible. So we have to come up with the first deployable one, cost-effective emergency communication network, and for all such kind of the situation. So out of the three phases I told, the pre-disaster, the last-minute backup, and the network deployment during disaster, out of these two, I will talk about the last-minute backup and the network deployment. So UAV assisted wireless network can be one such example of deploying the network can be of this type, where we are talking about a swarm of the drones. If we know in large, we know the geographical area where disaster is expected to happen. And already the disaster has happened, at least the first level of information wherever we have. We can deploy the swarm of the drones there. And these drones are expected to have interconnection between them. It may be a relay-based hopping network, multi-hop network, connected to the last base station's infrastructure network connected to. And it may be also connected to the satellite communication network. On the other hand, it may be actually a standalone network also, creating the part and then coming back. The whole network, some of those drones are coming back with the information. See, actually, all the three cases that I'm talking about, the standalone or getting connected with infrastructure, LT core network or the 5G network, or getting connected to the satellite, whatever is it, that can be dynamically set up. And last of all, we can also think that this network can be a cloud radio access network based network, so that for the cost-effective deployment, we can think that these drones will be carrying only the radio resource heads. So there won't be any baseband processing as if going on. But in a fast, effective fashion, they will be taking up the informations and trying to establish also the communication to the last mile, where the basement processing units we will be loading to the infrastructure network also. But all this depends upon the depth of the disaster that is happening. So if you see inside the drone, if it is the complete network going to form, so it will be having its own flight controller, its own system of the communication system, its own routing and protocol running on it. So in the IIT Kharagpur campus, we have come up with such kind of the network. We have we have integrated the drones in-house. We have parts of the drones we have also inbuilt in-house and then integrated on this. And the quadcopter designs are also actually inbuilt. We feel, as an example, we have tried to develop a Wi-Fi based network with the help of the swarm of the drones. But for a practical use, we can have the drones to be configured for the as a femto base station or a micro base station, a WiMAX or a Wi-Fi connected one. And definitely they will be having a different range, different height, and a different number of the user coverage as well as a geographical area coverage, depending upon the energy that you are supplying to them. Tomorrow's the drones will be coming up also with the solar powered battery cells and also the energy harvested circuit systems imposed on the drones. Drones are also coming up with the VLC communication added to them to give the power efficient communication. So there may be a multi-rat technology, the way we are thinking about for the upcoming cellular. We can parallelly think for this kind of the communication system. Once you come up with such kind of the designs, there are several challenges. First of all, the challenge is you have to come up with a dual network connectivity. One set of connectivity should be with the user ends to establish the connection. Another set of the network has to happen that within the drones, as well as with the infrastructure one. If you are thinking that it should be last mile connection, it is an extension of the last mile connection. So if it is a Wi-Fi based, you can try out with creating a dual hotspot, dual Wi-Fi connection, one acting as an hotspot, another is working as a pure Wi-Fi connection. I'm not talking about any very typical Wi-Fi technology. Maybe it is a G or N or a C or a D or even 6, but it can be explored. We have tried with certain version of this Wi-Fi for a testing purpose. And the most important challenge that you will be having is the auto synchronization. And what I mean by it is once actually the initial location is available and the master drones are flying, the automatic network should be capable of managing its own location, so reorient the location as per the movement of the user ends, as well as the way the disaster is progressing. You may not have the initial information the way the disaster is progressing. Once network is deployed, you have to collect the information and then reorient the network. So once we try to reorient the network after the initial deployment, you can plan initial deployment by a lot, but once you try to reorient it, the synchronization among the drones you need to re-establish. As well as you may take care of the artificial intelligence based multiple algorithms can help us to go ahead with the instantaneous localization and then help us in reorienting the network with the power constraint fashion. Another important task and challenge that we face during this connection is that auto reconnection. For example, maybe any one of the drones in the swarm started malfunctioning when it is deployed. Then there will be a sudden disconnection, and you need to the whole other drones needs to estimate that one, and they need to reconnect. The auto reconnection and re-establishment of the network has to happen very fast. So how this detection will happen that any one of them are malfunctioning, and how the adjustment of the heights of the drones can help us to reconnect the network with the other one. I mean to say that it may be a line of sight connection re-establishment. It may be the one approach you are doing, or it may be actually some other rat wise you can may turn out to bypass the damaged one and then reconnect it. So you have to have some mechanism imposed there. The fourth challenge that we will be having is some user-friendly platform you have to carry with the drones, so that actually you can alert the survivors and exchange some information from them. You cannot expect that all of their mobile phones will be they will be in a situation to handle their mobile phones at the time to get connected with the network. Biggest question will be that how will they know that there is an emergency network getting actually deployed there, or it is currently existing. So it is a task of the network to enable the connection on the user end. If the mobile phone is active, it is powered on, so you should be able to download automatically. Network should be able to download automatically some user-friendly platform to extract the information about the users and the survivors. And if possible, then how can you extend the network with the help of the existing some of the Wi-Fi connections, like a Wi-Fi connection there existing inside the turned on mobile phone, so that they can help you to extend the connection in the victimized area. So as I was telling that the most critical portion was the synchronization algorithm design, how actually on auto-guided mode, the one drone will be guiding the other drones to fly automatically without any intervention from the ground station. And we came up with some modified PMM-based algorithm, which is a collision avoidance-based network connectivity we could establish there, where the master drone first took off, and every moment actually it was measuring the RSSI coming from the slave's part, and it was also controlling its speed over the, so that actually to maintain a minimum amount of the RSSI, satisfactory amount of the RSSI I should say. And this trial basis movement control that we have imposed there controlled us, allowed us to go ahead with the whole deployment of the swarm of the drones. And of course, actually, we gave the initial location to the master drone, and other guys actually got their location information, related location information, guided by the master. These are some of the field experimental results that we have done in our campus. So the first experiment was to assess the network performance between a user and the node when this wireless network was deployed on the drone-based cases. And especially we wanted to know that what is the maximum hop distance possible, I mean the communication range between the drones once we form the network. The second experiment we did actually for testing the surveillance of this whole network. This was done in-house. This is currently a test bed inside the campus and in the School of Telecommunication in Kharagpur, where we test a lot before we start flying. We test the whole connectivity of the drones over the multiple connections, where we also test the relay-based connections. We test actually the extension of the network connectivity part. We test whether actually the voice, video, as well as the any multimedia traffic can be nicely transferred from one section to the next or not. The last important part was actually the actual experimental setup. Once the experimental setup 2 is passed, we send it to the field experiment setup, where you really get the wind turbulence and you test your algorithms on the field test. I will show something later on the results that we have obtained from the field test finally. And I have already explained about this drone test beds, and some of these results are already published in the transactions. Now the next important pillar, which was the last minute backup. As I was telling that, suppose if we develop an app and we get an early information that disaster is expected to happen. For example, if it is a heavy rainfall going on, this year it has happened. So the hilly areas, the mountain areas like Darjeeling and all others, so we can measure the amount of the rainfall that is happening and when it is crossing the border. So it brings actually the landfall, and we get the approximate idea that it is going across the threshold, so it may bring the disaster. We can immediately intimate all the service providers who are having their base stations nearby, who have their DCs there nearby, And they all can get alert, as well as the alert may come to the telecommunication service providers and the disaster team. So first important point is, I mean, we have seen actually in the Uttarakhand flood, we have seen during the Kedarnath that once this telecommunication infrastructure is damaged, the information that we lost at the last few moments, it was actually the most valuable part that we could not retrieve even. Some of the information were very, very critical also in the infrastructure. So question starts like this: even if actually we get the alert, how fast can we have a last minute backup algorithm to evacuate the information from the going to be affected area, telecom structure? So target will be multifold. You minimize the total duration of the backup, maximize the total amount of the backup. You select the multiple backup so that risk and safety factors are minimized. Your algorithm should be aware of the progressive disasters, because that's a dynamic way the progression will happen, and you have no idea. I mean, your algorithm should be capable of coping itself with the progressive disasters. So immediate backup selection has to be dynamically updated and selected and changed in terms of the way the progression is happening. You, if possible, actually, that you should be able to quantify the risks associated to the endangered disease, and some kind of the prediction has to happen that the way the progression may happen and towards the direction of the endangered disease. And finally, designing the link selection algorithms for maximizing the risk avoidance. So these are a typical situation how the backup disease centers and the disaster zones, the way the things happen, and we consider that the way the backup algorithm should be initiated, and it should keep on going. We tested our algorithms on the US network, and came up with the three different tasks we identified for this backup cases. The first task is that you should have a risk-aware path provisioning. So selection of the path, you have two things. You have to select the path in such a way that your commercial communication that is going on, it should be less hampered, as well as your backup should be taken out. The third thing is that you are dealing with a time varying network, because progression, with the way the progression will happen, you have no idea. Task 2 has to happen that you are going to use a wavelength allocation, and you should have the knowledge of the risk aware the path provisioning on the time varying network. So wavelength allocation and the risk aware backup wavelength and pair allocation, these are the two major tasks under the task 2. The third task will be the risk aware adaptive reconfiguration of this whole backup algorithms. So we have come up with the three different kind of the algorithms, where the first one and the last one talks about the dual DC backup, and the medium one is called talking about the single DC backup case. I'm not going in detail towards these backup algorithms designs, and it may be seen in the transactions on networking came up this year. So this is one example, the way the disaster progression progresses over the time. So the leftmost one will be showing us the position of this fast DC number 2, suppose. And this is the center from where the disaster started. Maybe it is an earthquake happening. The first wave, when it came, it damaged the L23, L13, and L12, all these three parts. And once it is progressing, in the next level, your DC3, DC1 will be in the
Ms.
endangered
Debarati,
zone.
can we try to wrap up because of the time? I don't know how many
Yeah,
slides
sure,
you
sure,
have.
sure,
Thank you so much.
sure. In 2 to 3 minutes. And so this is the way the progression will be happening, and your network will be keep on changing. The right side figure is talking about. And some of the proposed algorithms that we have come up with has shown that the backup success rate with the proposed one can reach more than the in 90% cases with a very short duration within 3 minutes that we targeted for the earthquake cases. I would like to show you a test setup results that we have done in campus. This is the auto synchronization. This is happening, and the auto placement of the network will happen automatically with the flying base station. The flying station. So this is my team. Thank you.
Yeah, thank you very much, Ms. Deborah Thyssen. It's a very interesting project, wind project. The video was a little, breaking up, but hopefully this presentation, when uploaded to the website, we're able to download it and watch it in high quality. But I think it's a very good piece of research work, and I hope we can leverage this in the context of critical communication.
Thank you.
Yeah, thanks again. So, as far as the agenda goes, we have one more keynote from Professor Sudeep Misra. He's unfortunately not available, on this meeting, but we have a recorded video, and due to the time constraints, I propose that we not play it now because then we would, disturb the entire schedule. So I hope that's okay, and we will reach out to Professor Sudeep on this situation. So with that, what I would like to do is, I've not seen any questions, Professor
One
Debrati,
small question.
or is there questions? Yeah, please.
Yeah. To Madam Sen, one small question regarding drones.
Yes.
It's can you just tell us the what is the maximum range which can be achieved through drone, and how many maximum customers of 3G and 4G can be dashed with one drone? Say in a disaster-prone area, as you projected that multiple drones can be interconnected, and
Yeah.
the link could be on fiber or radio-based drone, I believe. Will be a radio-based drone, and it can be connected to nearest BTS also of any TSP.
Yes.
Can you just throw your views on this?
See, it depends upon the technology that you are deploying. Suppose if it is a Wi-Fi based technology, then it can go up to 500 meter flat between drone to drone, I'm saying. And it also depends upon the height than which you are placing the drones. It depends upon the height placement, also the coverage on the ground. But if we are going ahead with the 5G base stations deployed over the drones, and size of the drones will be bigger than what I have shown in the video, in that case, it can be covering more than the kilometers. So basically, that's why I was showing a typical table on technology versus the distance and the weight of the drones. It is a balance between these three. And as actually, I was telling that the height as well as the size of the drones play a very critical role on it. It also actually help us to understand how much amount of the energy and then the battery power that we will be able to give as a payload. So to give you the answer, if it is a pure wireless, and as it's expected to be, and also not only the battery powered, it is also solar powered enabled and energy harvesting enabled, then we can, with the 5G base stations, we can cover more than kilometers. Minimum 1 kilometer has to happen.
So there is a question if we can adapt this for LTE, and I think Professor, you already mentioned that it's sort of independent of the technology. You can adapt this to
Yes, yes.
LTE or Wi-Fi.
So yes. So the communication module that we have designed currently is Wi-Fi based, and we have also tested with the 5G one. So it's a changing of the payload, the communication module over the drones, and depending upon their design, the coverage will be varying.
Okay, great. So thank you again very much for your time and the excellent presentation. So over to you, Pranav. I think we have about 25 to 30 minutes. I think we can do it for 30 minutes. So maybe a quick introduction to the panelists who have not been introduced, and then we go on to the panel.
Yeah. I mean, we will try to wrap it up by the time that has been assigned to us. So thank you very much, Suresh. And I would also request Professor Sain as well as Bill to stay if they can and share their viewpoints wherever it is relevant for their work. So if they have time and if they can stay on till the end of the session, we will be really thankful to both of you. So let me introduce two more panelists, so the first panelist we have is Dr. K.L. Shekhar. He's a senior professional in disaster management who serves as the member secretary of Kerala State Disaster Management Authority, and he was the head of State Emergency Operations Center for a considerable number of years. He's currently on leave from the government of Kerala and is working at Faculty of Geoinformation Science and Earth Observation, University of Twente, the Netherlands, as a visiting scientist. The other panelist we have is Dr. Krishna Kumar Agarwal. He's a director at the Department of Telecommunications, Government of India, and he's looking after the BharatNet project, which is there to provide broadband connectivity in rural areas in the country. And he holds an MPhil degree in public administration, a postgraduate diploma in public policy and management, and then a master's in telecommunication systems engineering. He has more than 20 years of rich experience in the field of telecommunications. So thank you very much, both of you, Dr. Shekhar and Mr. Agarwal, for joining us in this session. And so maybe we will start with you. Other panelists were able to speak, but we can start with some of you, some of the questions with you, Dr. Shekhar and Dr. Agarwal. So is that okay?
It's fine, Mr. Pranav.
Yeah. Okay. Thank you. So maybe the first question that I would like to request Dr. Shekhar to answer is that what are some of the key usage scenarios for critical communication in India, and the scenarios that are perhaps unique to the country, and based on your experience in disaster management and so on, can you please share some of your thoughts?
Well, I'm not an expert in telecommunications networks, but I am a user who had been using this for quite a long time. As you can see, I had been managing disasters for umpteen number of years in my life, and it's always had been a problem that we primarily rely on a lot of existing available networks like the GSM or the public radio service, which is by and large an LRM. And of late, we have also moved into satellite radios. But what is very interesting is that many of it doesn't cater to the needs that emerge in times of disasters, and also for selected set of communities within our ambit, within our country. I must tell you that under the Sendai framework and the SDG goals, inclusion is what disaster management authorities try to do. So we would like to actually include everyone in the process of disaster risk reduction. And then it is often found that there is a critical lacuna in terms of possibility of communicating with people who are probably not as privileged as many of us. I will cite few examples, and then probably those are the lessons that you technocrats will have to solve for us, the managers, because ultimately we work in the interface of science, policy, and execution, where we adopt science technology to facilitate in times of the highest need, which being disasters. If you look at 2017, when Kerala faced a critical cyclone along the coast of Kerala, actually didn't even come into the Kerala coast. We had Cyclone Oki, which actually killed about 300-400 people in Tamil Nadu and about 150 people in Kerala. But most of these people who died were actually in the sea when the cyclone suddenly evolved. And I mean, but for all technical developments in the front of meteorology, we still have had difficulty in detecting the fast evolving low pressure, which turned into cyclone in less than 8 hours. Nevertheless, when we saw that there was a low pressure that was forming, it was not possible for us to communicate beyond maybe 12 kilometers into the sea to people who were already hundreds or even tens of hundreds of kilometers away from the coast of Kerala. And we must realize that these fishing communities, unlike the Scandinavians or the Americans who goes out in Pakka built boats with all kinds of safety equipment. I mean, many of us would have seen the North Sea hunt for the great crabs or the tuna, but our fishermen are by and large very indigenous in their equipment. In their approach towards safety, they are still very rudimentary, and that's also because that they're very maverick in nature. Inherently, for example, the southern coast of Kerala has a community of fishermen who does long range fishing using fishing lanes, and they are specialized in hunting sharks. So these people, they travel light. If you tell them, well, you carry a battery and then you carry a satellite phone and then you have a deployable antenna, then you have GNSS and then GPS, well, they are not such people who wants to listen to all of that. And that's probably because they want to travel light and they have rather limited equipment. So this crisis still remains. And then with the help of Indian National Center for Ocean Information Services, we tested a satellite-based unidirectional communication. And recently, Gagan, a new platform, is coming up. But now from 2017 to 2021, it's almost 4 years, and we are still to facilitate in this country something that is affordable to the poor fisher community of the state or the country as such, to communicate bidirectionally. So they do use simplex radios, but then it has its own difficulties, and all of you are experts than me in knowing what are the difficulties of using it in rough sea weather. But and we also subsidized satellite phones and offered it to them, but they were not willing to take it because they believe that when they go out for a week or more, it drains out, and then there is a lack of possibility of charging it and keeping it up. And secondly, it's costly. It's still not affordable to them to recharge it year after year. So yes, this is very unique, and this is a solution that we, the telecom community and the managers together, has to find, wherein what is affordable to them. It has to also be light, and it has to have a radius of not less than 200 kilometers in the sea. Fishermen from Kerala had gone and fished in Digo Garcia, which is like 6,000 kilometers away. While 6,000 kilometers of communication seamless may still be an enigma other than through satellites, I believe it's high time that we facilitate something that is really affordable to the fisher folk. Yet another peculiar situation that I faced in 2018 when we had the great floods was that, well, we had deployable VSAT nodes in many of the points across the state, and we had it in many collectorates. But as you all would know it better than me, it was very clouded and it was very gray, heavy downpour. The systems were not uplinking, they were not connecting. So, well, while we have a redundant communication system which works other than through the POLNet, which works very well because it's still LMR and DMR. They are moving, police is trying to move into DMR, but then it's still LMR. And then we still, when we speak of a backend, a redundant system through Emersat, even that doesn't work. So the situations evolve in such a manner that it's so very difficult when the real thing strikes. So we had to move in cows. We had to facilitate the Indian Army. The Indian Army's engineering teams facilitated to Reliance Jio and BSNL to kind of literally lift up cows and put it in different critical points, and that was actually after 3 days or 4 days. And many of the terrestrial antennas that were available as part of different VHF communication or ham radio networks were again hitting problems because one, battery charging, there's no power. We are still in the lead acid era. We should actually move into lithium ion era, probably. Something that I had been trying to do, at least in our State Emergency Operations Center, to move out of lead acid. So these are things that are practically faced, and given the difficulty of the terrain where you have places which are below mean sea level, and there are places which are 2000 meters above mean sea level where people live, in a state like Kerala where it's so densely populated, you have this great crisis. And then, of course, earlier I was listening to some of our speakers where they were talking about user-driven coverage. This is actually a problem that I urge upon all telecom companies and the facilitators, the technocrats, to solve. 2020, we had a landslide in a remote area within a tea estate, and the nearest optical fiber line was like 26 kilometers away. I mean, where are we? We are the cheapest in the world in terms of telecom. I don't even use a mobile phone in Netherlands because it's so expensive. Coming from the India and trying to use mobile phones like for €2 or €3 for a call, I can't imagine that. So it's very difficult when you say that while we have great service providers, we still have such areas where geographically coverage is required because there are people who are excluded from the mainstream living. And that focus, how do you connect to them? How do you ensure that our telecom companies show a bit more of responsibility in extending it to them? This is something that we probably have to discuss. I have no solutions for all this. I can only facilitate from the side of the management. We try to facilitate. We work with them very often. DOT has a wonderful nodal team in place in Kerala, which meets every 3 months. We all interact to each other and we try to facilitate. But then these are things that need solutions for practical management. Otherwise, we will not achieve the Sendai framework targets. We will not achieve the SDG targets. Telecom has been always a big driver for doing this. So yeah, these are few points that I want to say. There are few initiatives that I will also illustrate in the next questions that I might have. But there are things that I also would like to speak about, community radio and all that. Thank you. As of now, I think these are things that I want.
Yeah, thank you very much, Dr. Shekhar, for sharing your insights based on your experience in disaster management and so on. These were really very helpful. I would request now Mr. Agarwal to share some of his thoughts on the usage scenarios that are very important for our country. So over to you, Mr. Agarwal.
Yeah, again, good evening, everyone. And let me thanks every speaker who had nicely covered most of the topics in emergency communication. and it was really wonderful talks on drones and this 5G and IoT use cases and other topics. And Mr. Sekhar, he has rightly pointed out that there is some sort of communication gap in the deep sea or for the fishermen or even for Navy personnel. So there is a need to strengthen the satellite-based communication in the deep sea area, where right now the Denmark International Maritime Satellite that BSNL is providing services. Satellite phones, they work in the deep sea area. Many Navy and other paramilitary forces have taken these phones. And these phones has also broadband nowadays. The began services have started across the globe. So this is very useful for providing communication to fishermen and for other Navy people and offshore oil companies and all these things. Recently, some disaster was happened near Bombay High. Though message was given, but cyclone was of so intensity and it was built up further, and they have ignored that information, and finally that entire deck was collapsed and many people have died. So enforcement agencies should also implement it forcefully so that human lives and assets can be saved. Finally, the Air Force and other paramilitary forces has roped in so that many people have been saved. So it is a need of ours that every probably there is a need, really need of increasing satellite communication, penetration, satellite phones, their bandwidth, and now with HTS satellite, high throughput satellite available in the country, so there is no probably there is no much issue in using this satellite phone. And second, another means in hilly or remote areas, again satellite communication plays very important role for providing backhaul connectivity for 4G, 3G towers, and now 5G is coming up. So we cannot ignore satellite communication as a media. Though OFC is available across the country in metro, mini metro, and in rural area, BharatNet is there. But BharatNet phase 1 is and phase 2, some 1.25 lakhs or around 1.5 lakhs gram panchayat is already connected with the optical fiber cables and Wi-Fi. So this many telecom companies are using that fiber for providing 4G and other tower connectivity. So still, but digital divide is there. There is a need to get broadband penetration into the area. So what I feel that for disaster communication, there is a need to have an integrated network. As of now, the paramilitary forces are using fragmented model or narrow-band broadband communication. CMRTS, PMRTS kind of radio, they work within the city, and or even sometimes the coordination and communication. They cannot share videos when some disaster happens, if some train accident happens. Only that. So there are try recommendations on this, which is going on. Broadband PPDR network, which we are examining, and it's underway. Government is thinking to implement it, but there are certain issues of spectrum and funding. Probably MHA and other agencies We hope that will take some shape in near future, and because this 5G will also play a critical role in the upcoming network, because with IoT and other devices and URLLC kind of services will further enhance the relief and rescue operations. So this is my view.
Thank you very much, Mr. Agarwal. I am not sure if because we just had time till 7:15. It's already 7:11. So I am just wondering. Maybe I will ask Bindu. So what should we do? Should we conclude the session here? Unfortunately, we can't discuss many of the questions and the points that we had, but or can we extend it for a few minutes and then maybe seek everybody's views, in summary form? So Bindu, maybe can you please suggest what can be done?
She not on stage.
Oh, okay, sorry.
For
So then, Suresh, what do you think?
No, I think if the panelists are okay, we could extend for about 10 minutes. If the panelists are fine, because hope 10 minutes is not too much, so we could go up till 7:25, 7:30 maximum.
Okay.
I think that's fine. Yeah. Thank you.
Yeah. So then, So maybe then I will, I will request, Tero to share some of the thoughts that he would have liked to share, because now I think it is difficult to go into all these questions. But hearing some of the views from Mr. Agarwal and Mr. Shekhar, if Tero can share some of the thoughts, for our country. Yeah, thank you very much. Yeah.
Thank you very much. What comes to my mind is it's quite important for us to work together globally for these solutions and verify what is the best means for any particular situation and case. In our country, what we have learned very strongly is the need for the success comes through cooperation. So for instance, we have a service where we have all the mobile operators, all the key grid operators from the utility side as well as telecom side, and the key public safety stakeholders meeting every week and having, for instance, a weather forecast for the coming week, where they then jointly make preparedness plans if there is anything, if the risk is increasing, that there needs to be preparation. And with this, even though the mobile network operators are competing with each other, they still agree that, look, we focus our forces to restore the network service in that area, so you focus your forces in the other area, so that the ability, for instance, to call the emergency number would be restored as quickly as possible to all citizens in given spaces, and that has been quite successful. So national and international cooperation is strongly a key. Being practical, maybe other aspect from TCC point of view. Why are we trying to reach critical communication in 3GPP? One big reason is that we believe that on one side, when we use technology which has been designed for billions of people, there's a lot of investment into the technology innovation, so we can push that forward. Secondly, we believe that when we work together with the mobile network operators, they have a business case in preparing the services in those areas where potentially tax funding would not be sufficient and adequate. And in that sense, we quite humbly try to find solutions which are multi-purpose use, not only for mission critical use, but also bring benefit to enterprises and others and that builds the business case for the mobile network operators, well, other parties to implement, and then mobile network operators to roll out the service so that it's then available when mission critical service is required. Maybe these were the couple takeaways.
Yeah, thank you very much. Thank you very much, Tero. So maybe then I will request Professor Girdhar to share, a few thoughts which he would have liked to share, in the light of the comments made by Mr. Agarwal and Dr. Shekhar. Yeah.
Thank you. So I'm just responding to, first of all, the comments made by other speakers, as well as the list of questions which were put up. Before I go further, I think the questions were very thoughtfully done. So I congratulate TSDSI, which has put together this set of questions. Now, while I agree with the exponent that it's important for looking at standards, there are particular issues in each country which have to be addressed at the country level, with innovation happening only within the country, which has not happened in India, which is a shame. And when I say that, I say it with a lot of humility, because I'm aware of what 5GA has done, which is a starting step, but we are looking at something being done which actually addresses the Indian subcontinent, and like that maybe other countries. Let me just point out where we differ. For example, one thing is that we see more precipitation. Countries like India, Malaysia, Indonesia, they see more precipitation, so link budgets are poorer compared to cooler countries. We know that. Even for point-to-point links, the link margin I need to give will be much higher in India than in other countries. Moving forward, when I talk to people from other countries, including countries like Israel and so on, especially during this pandemic when people are doing work from home, learn from home, and so on, now people, when they look at technologies for broadband access from home, they are talking about tens of megabits, because their device, even for example, when children want to learn from home, school environment, they are looking at connecting through their set-top boxes or DSL or something and getting 10-15 megabits so that they can be immersed in the class, right? The immersive experience. But as an Indian, I can get immersed on my small form factor, small mobile at 1 Mbps. I can get immersed and learn from it. And there are so many children in India today who are learning their schools just from mobile phones, not even from a laptop. Hats off to them, and they are still doing very well, and hopefully, keeping their bits. So in other words, the bit rates we need, even for basic access, can be much less. Link budgets can be poorer. Network topology can be different. The TV UHF band, unlike, I know, for example, in the US, I know the TV UHF band was given to various private players. Many companies have their own 10 megahertz, 20 megahertz of spectrum in the TV UHF band. But in India, it is just with one entity, which is the government. Right? Mr. Agarwal can correct me if I'm mistaken. Only the government, only Prasar Bharati has access and DOT has access to the entire TV UHF band. So there are opportunities here where we have underutilized spectrum, where proper technologies good for India can be brought in. Yes, we will take help from the world community, but we need to drive this from the Indian perspective, which we have not as a country. And if we do that, some of the things for example, what Mr. Shekhar said, right? 200-kilometer link is very easy to establish. You talk to any wireless expert, the link budget to get 200 kilometers is not very different from going to. I mean, it is higher, we agree. But the issue is not actually the link budget. How do you work in the context of interference? How do you get high rates? Right? How do you manage? Of course, there are network layer issues. How does your medium access behave? The latency is higher. There are issues. We are not doubting it. But we have not really, as a country, we have not imagined the solutions what we need as a country and done it. Though the government has been supportive, it has not been supportive enough in working with private industry in India to make this happen. That is the truth of it. But I think now is an opportunity in SA6 and with kind of people whom I am seeing in this kind of gathering, we can operate world standards. But as I said earlier, the fact that we can have our own bandwidth partition and network slice in technologies like IGNR allows us to now innovate as a country and come up with good solutions. And later get ratified with ITU or with 3GPP. We'll get it. But I think we need to drive it. And, I think this is a very good move what TSDS has done to facilitate this kind of conversation. I have made new friends now, and we can do much more from that.
Yeah, thank you very much, Professor Girdhar. So maybe we don't have much time now, so I will quickly come back to Dr. Shekhar. I know he wanted to share some thoughts. He mentioned that, so I would request him to, say whatever he had intended to. Yeah, thank you very much, Dr. Shekhar. Yeah, please.
Thank you, Pranav sir, and others. Much of what Professor Gurither spoke was kind of far above my head because it's all communication, but well, the problem needs to be solved, and that's all what I am interested in, and I think you're great minds to solve these problems for us. But in the meantime, I wanted to present a little case here for the consideration of TSDI and the telecom experts here. Post 2018 floods, we had been actively involving community radios, number of channels which are there in Kerala for spreading the message of disaster risk reduction, but also at the same time to communicate. We have over time kept the radio in the back end, and I think radio still remains that one reliable source of information or one reliable thing through which we are able to communicate. And I really realized as part of that experiment, and then with the help of NDMA, we also tested the medium range transmitters that are lying in Kerala with the Prasar Bharati. We realized that a lot of these equipment are still there, but is not being used. And then we came up with this idea, and we wrote to NDMA, and I think we also wrote to the telecom ministry, suggesting that there be a dedicated channel, like in the US, for communication in times of disasters, particularly if at all unidirectional, at least unidirectional, that goes through the transmitters that AAR has across the country, which can go long distance, and the fishermen will also be happy if we also budget up with some songs and local colloquial discussions, but then they will be aware of what is coming their way. And the terrestrial beings like us, who doesn't step out into the water for fear of the big waves, we also will benefit from it. We found that community radio was very effective. UNESCO and a firm in Delhi actually helped us. It was Radio Sync, I think. They also helped us in doing this whole exercise with the community radio. So I urge upon all of you that we campaign for a dedicated emergency communication channel, and that we bridge all the abandoned or underutilized communication networks of AAR and put it into an integrated platform, so that at least when emergencies strike or when we have anticipated emergencies, we could utilize that to provide right kind of communication to public. I believe all of you will agree to me when I say that radio still remains that one reliable channel for public to know across the world, and I really use this time to urge upon you for that. Thank you. Our study report is available in our website in sdma.kerala.gov.in. There's a very detailed recommendation that we gave. Maybe I can put it in the chat box here so you could share it. Thank you.
Sure. That will be really wonderful. So I will, come back to Mr. Agarwal on a dedicated, channel if he would like to share some thoughts on that.
I think Professor Gurither has rightly said that there is a some sort of underutilization of the spectrum also. But now telcos are they are effectively using it 3G, 4G, and some of them are upgrading to their 4G network in NSA mode to 5G network, IoT, and these things are URLNC kind of application. These things will really facilitate further for business communication as well as for critical communication for different parametry and different agencies. So regarding emergency communication number, already this NDMA and DOT are working on 112, just like US 911. One number is 112 emergency communication number. So anyone having normal phone can also call it, and that particular location will be reached to a state emergency operating center, and that any disaster first responder, SDRF or anyone, they will go and try to save persons in distress. So, I mean, this number anyone can use, the person who is using 3G or 2G or 4G phone, because still India has some 40% people are still using 2G phones because of low status of income. Slowly they may migrate to 3G and 4G smartphone. So, besides this, there are other helplines. 1070 is there, and there are other technology which is, say, common alert platform is there that across the nation. In phase one, this gap alert system is being implemented. So a targeted area where disaster is likely to happen or is happened, say in case of cyclone, say East Coast, West Coast, India is quite vulnerable to these cyclones and flood. So people in a targeted area can be alerted through customized messages so that they can be saved. The CDOT is implementing this project. So this will help to evacuate the person and people, and it is very helpful. Though there is some delay as of now. So from cell broadcast service, CBC is coming up. That is, the delay will be of some 10, 15 or even 20 seconds in that. So, I mean, the CAP Common Alert platform is very useful. It is used in COVID platform also. So during COVID, persons who are, in quarantine centers. So if someone goes out of quarantine center, the CQS alert system will alert the enforcement agency, the police agency, and they will catch hold of that person and they will, put it again so that people, the COVID spread can be stopped by this. So there are many multi-technology which will help in this for instant communication, so or critical communication. Drone is very important. Still, very TSPs are telecom operators. Very few are using it. So radio drone will be very helpful. Say, in case of cyclone, large area becomes cut off, especially coastal and border areas where mobile towers or their BTS, their reorientation becomes or there is damage. So it is observed that some 2-3% or 5% BTS is down. So in that case, the drone will be very helpful. Or cow is still people are using TSC, are using, and satellite phones. So the multiple technologies will help to facilitate the agencies to save the human life and evacuate the persons and further for relief and rescue operations. So then agencies need to have a broadband public protection disaster relief network, just like US, UK, they are using FastNet. So India, it is the high time that India should have this kind of network. And then cyber security is a emerging threat which is coming all of it. No PSPs or ISPs are using cyber security measures, but still there is a many gaps, and any financial network or telco network can be attacked through cyber security is a very important aspect that needs to be inbuilt in disaster relief. It's a proactive approach. This is probably required. So these are the things. And then by upcoming 5G technology will really help to further facilitate different agencies for the rescue operations. Thank you very much.
Okay. Yeah. Thank you very much, Mr. Agarwal. So I think now we reached the end of the session. Unfortunately, we could not do it the way we wanted to because of the lack of time. I would request Suresh to, share the concluding remarks, and then maybe we conclude the session. Yeah. Thank you very much, Suresh. Yes.
Yeah, thank you, Pranav, for running the panel session. Obviously, we couldn't cover all the questions that we planned, but I have to say it was a great panel discussion, with at least getting some key perspectives from all the panelists. So let me just try to conclude this session by saying that I think there are some key takeaways from what I was able to kind of jot down here, especially from the panel. We did touch upon the user coverage versus geographical coverage aspect again. That sort of came out as a key point that I believe the community should look into. And we talked about the integrated network, combining various technologies, and this is an ongoing subject where we all understand that one technology will not solve all the problems. So we will have to look at some sort of an integrated approach. And then I would like to kind of maybe pick up from what Professor Gurither and even Debrati Sen mentioned, is about how do we take some of the local research and innovation to standards. So that remains to be a key critical aspect, especially considering some of the unique challenges that we have locally, which probably we have more knowledge on. And then, as far as Tero's presentation and Bill's presentation, I think the emphasis has been very strong in terms of coverage, availability, resilience. I mean, these are all common themes, and I hope those are very clear. We also talked about what is the best way to transition from narrowband to broadband, technologies, because for obvious reasons that broadband is much better in terms of bandwidth and so on. And thanks, Bill, for giving us a walkthrough about how you have kind of achieved or arrived at where you are. I think that's like I said, great blueprint for us, for a country like India, where we are still at the very early stages. So it's, I think, especially I would say, probably Mr. Agarwal, DOT can kind of take some cues, not only from the FirstNet, but also I think Tero covered largely what's happening in various other countries. And thanks, Professor Gurither, again for your case studies on interference limited coverage, and also the multi-operator spectrum sharing. I think these are very good subjects. Debrati Sen on your last minute backup and SWAN of UAVs and the synchronization. Obviously, these are more at a research level, but hopefully, we can sort of take them to a more, I would say, standards way, or kind of find a way where these aspects can be commercialized to take advantage of those. And Dr. Shekhar, very nice to have you from Netherlands. Even though you are on leave from your work in India, I think you brought up some very good examples, real life examples, which I think we will try to document and try to evaluate from a technology point of view what would be possible locally, but also at a global scale. I hope I didn't miss, and of course, I want to thank Pranav, my co-chair, for conducting the panel session and helping me throughout this session, and the entire TSDSA community for organizing this session. Obviously, we are time limited, but subject is so that we can keep speaking for a long time. With that, I would like to thank you again, all the speakers, panelists, and all the audience who have been patient with us. I hope we have some work cut out, all of us, and I look forward to staying in touch and continuing these conversations. So thank you all. I think with this we can close the session. Have a great week and rest of the year. Thank you.
Thank you.
Thanks, Suresh.
Thank you very much. Best of success.
Thank you. Bye-bye.
Thank you, Mr. Suresh, and everyone.
Thank you very much, everyone.